All right, today we're going to do something really cool. We're going to peek inside your computer and meet this amazing little helper who makes everything, and I mean everything, work.
Have you ever really stopped and thought about it? How does your computer actually think? How does it play your favorite game, or pull up that funny video, or even help with your homework? It just seems so smart, right?
Well, you might be surprised, but it's not magic. The secret is this tiny, super-duper fast helper who's hiding inside every single computer, and he's the one doing all the heavy lifting for us.
Now, this isn't a real little man, of course. He's a fun character that clever computer scientists came up with a long, long time ago, just to help us picture what's going on deep inside the machine. So, you ready to meet him? Let's go! It's the little man!
Okay, so first things first. Let's take a little tour of where the little man works. Think of him as the computer's brain, what the pros call the CPU. And his office? It's kind of like a super busy mailroom where all the action happens.
So, look around his office. See all those tiny little cupboards? Those are his mailboxes. He's got hundreds of them. And that's where he keeps all his letters, everything he needs to remember, like numbers, words, and even his to-do lists. In a real computer, we just call this memory.
And check this out. On his desk, he's got this awesome tool, a calculator. But, oh man, this is no ordinary calculator. This thing can do math problems faster than you can even blink. It's basically the thinking part of the computer, where all the adding, subtracting, and big decisions happen.
So, how does he even talk to us? Easy. He's got his in and out trays. See, when you type something on the keyboard, it's like you're dropping a little note into his in tray, and when something pops up on your screen, yep, that's him putting his finished work in the out tray for you to see. Pretty neat, huh? Okay, so we've seen his office, but what does this little man actually do all day? Well, it's a really simple routine. He just does it really, really fast. Believe it or not, the little man's whole job is just to follow a to-do list. We call that list a program. He just reads one thing on the list, does it, and then moves to the next. Simple. But here's the mind-blowing part. He does this millions, nope, billions of times every single second. Can you even imagine that?
Yeah, his whole day is kind of like a little three-step dance. It goes like this. 1, he fetches the next instruction from one of his mailboxes. 2, he decodes it, which is just a fancy way of saying he reads it to figure out what it's telling him to do. And 3, he executes it. He actually does the thing. Fetch, decode, execute, over and over and over again.
Okay, this is where it gets super interesting. Let's look at the very first design for the little man's mailroom. It's a really smart idea called the von Neumann architecture, but it had one tiny little problem.
So in this original mailroom, everything was stored together in one giant cupboard full of mailboxes. His to-do lists, the instructions, were right next to all the numbers and words he needed to work on, the stuff we call data, all mixed together in one big place.
And because it's all in one big cupboard, there's only one hallway to get there. Just one single path. In a real computer, they call this hallway a bus. So he has to use that same hallway to get an item from his to-do list and to go get the numbers for his calculator. See where this is going?
And yep, here's the problem. Just like a hallway at school, only one person or one piece of information can go through at a time. So he can't grab an instruction and a number at the same time. No way. He has to go down the hall, get the instruction, come all the way back, and then go back down the same hall to get the number.
What does that sound like? Uh-oh, a traffic jam. It totally slows him down because he's always waiting for that one hallway to be free. And this exact problem has a name. The smart folks call it the von Neumann Bottleneck.
So, a traffic jam. How do you fix it? Well, some really, really clever inventors thought about this and came up with a brand new design for the mailroom. It's called the Harvard architecture.
And their big idea was actually pretty simple. They thought, instead of one giant cupboard for everything, what if the little man had 2 separate cupboards?
And that's exactly what they did. They built him a mailroom with one cupboard just for his to-do lists and a completely different second cupboard just for all his numbers and words. So cool. And here is the absolute best part. Each cupboard got its very own hallway. 2 cupboards, 2 hallways. So now the little man can zip down one hallway to get his next instruction, while at the exact same time, he's zipping down the other hallway to grab a number. No more waiting. That traffic jam is gone.
Okay, so you're probably thinking, wait a minute, if the 2-cupboard design is so much faster,
Why don't all computers just use that one? And that is a great question. Turns out, both designs are really useful, but for different things.
See, the one cupboard design, the von Neumann one, it's simpler and way easier to build. That's why you'll find it in most of the computers we use every day, like our laptops and phones. But the two cupboards design, the Harvard one, it's a bit more complicated, but man, it can be so much faster. It's perfect for special computers that need to do one thing really, really fast, over and over, like the little computer in a car's engine, or even in your microwave.
And there you have it. That's the secret of how the little helper inside your computer gets all his work done. It really all comes down to how his mailroom is set up. So that leaves me with one last question for you. If you were an inventor, what kind of clever mailroom would you design for the little man? Maybe one with 3 cupboards? Or a circular one with a slide? Who knows? The possibilities are totally endless.